So the next speaker will be Fredy Dinkel. Fredy is environmental consultant at Carbotech and senior lecturer at the University of Applied Sciences, the FHNW in Switzerland. And after these LCA results from SpotView, we will now go get some insights into the results of LCA and LCC that were done in the INSPIREWATER project. And his title is Environmental and Economic Assessment of INSPIREWATER Solutions for Resource Recovery and Process Industries.
So thank you, Dennis, for the introduction, and thank you also, Ellery, for the introduction to LCA you have done before, so I can make this very short. In the project of INSPIREWATER, I will present you some results from the LCA as well as LCC that we have done, and when I say we, then it is my colleagues from FHNW and also the colleagues from IVL. They have done the LTC calculation, and of course all the industrial and technology partners, they provided us with the needed information to do this work.
May I ask you to lower the microphone maybe a little bit? It's loud. People on the phone are just...
Oh, sorry for that.
All good. Thanks.
Is that better now?
Yes, that's better.
Okay. So the overall goals of the LCC as well as the LCC was, of course, to detecting the environmental risk, the relevant environmental impacts, and so to also have a look at the potential improvements. And as also Ellery told us in her presentation, is that it is important to do that in the beginning and not only at the end of the project. So we really started at the beginning to see which are really the environmental relevant impacts. And then, of course, this means we go from a local view to a global view, because we go to the whole life cycle, and we go from a water to a resource management, because we have also here this morning in that there is this dilemma between water and energy, climate change, and how we bring this all together. And so, yes, I think Ellery has done a good introduction to LCA, so just 2 words. Of course, we also look at the whole life cycle, and we take into account a large number of environmental impacts. And of course, there is always this big question: do we now look more on energy, on global warming, or on water scarcity, and so on? So what we took, and you will see also in the results, of course, we calculated all these different impacts, but then we also used weighting methods, taking all these different environmental impacts into account. And I think this is important because they are not based on scientific evidence, of course not, but they are based on scientific consensus, social consensus, as well as also on political goals. So I think this is always better than just to focus on one individual indicator. So we have looked at these 3 cases: ArcelorMittal, Sandvik, and Clariant. We have heard yesterday what they do and what they have done. And even 2 of them are from steel industry. They are totally different regarding the relevances of the environmental impacts. For example, in ArcelorMittal, there for the cooling circuit, the water and electricity used is very important. In Sandvik, it is more the scarce element phosphorus, which is of crucial importance. At Clariant, there, being in a very in a region with very high water shortages, then the water consumption is dominant. So let's have an insight in these 3 cases. Starting with ArcelorMittal, the cooling water circuit. What you see here is that the most important impacts is coming from the water resources as well as from the energy. And then now we have to see what the different scenarios we are looking at. If they increase electricity to reduce water, how is the overall benefit of all? So here you see we look different solutions. I just focus here on the removal of solids. And as you see, the current situation and then 6 different scenarios. And what you can see from this slide is that 3 of these scenarios, they have really a high benefit, which means more than or about 50% or more reducing of environmental impacts. Some of them, they have specific also positive benefit in water reduction, which means the negative values, because in impacts negative means positive to environment. And especially if we look at the magnetic separator, which has an overall environmental reduction of the environmental impact of more than 60%, which is quite nice. So you can see from this scenario calculation what are the strategies ArcelorMittal can go to. Let's now have a look on the costs. This is the life cycle costs calculated by IVL. And this is really a nice picture because you see scenario 2 was a very good from environmental point of view, and scenario 6, the magnetic separator as well. And also from a cost point of view, these both scenarios, they have a very high reduction of costs. So, which means they are really eco-efficient. If you are familiar with the concept of eco-efficiency, it is this concept from the World Business Council of Sustainable Development, telling that there is a way they weighten cost and environment 50-50. So, which means in this case we have, if both are positive, of course, then it's really great. Now, let's come to the Sandvik case. Here you see that the phosphoric acid and then the sulfuric acid, they are really relevant. They are responsible for 95% of the environmental impacts. And also here we looked at 2 scenarios, which means the actual scenario as well as the inspired solution. On the left-hand side, you see a reduction of 25% in environmental impacts. On the right-hand side, you see a cost increase by 10% for this solution, which means that the eco-efficiency is quite positive. Not so positive, but quite positive. But the good message is that after we have calculated these results, Sandvik, they continued, and today they have also in costs a benefit of 20%, and then they have higher environmental benefits. Probably you remember from yesterday when Sandvik presented it, they presented the newest result, which was on February. They have done it. So it is better than we show here. Now let's come to the last case, to Clariant. And as I told in the beginning, here they are at Tarragona in a very water scarce region. So here 90% comes from the water, because there in this region water is really scarce. And then of course operation, effluent, others have a certain impact, and we have to look at it. Also here we calculated different scenarios, which means here the baseline scenario, which is what is today or was at the beginning of the project. Then a future scenario, which means the reduction of DOC in the effluent because of legislation, which doesn't bring a really high reduction of the overall environmental impact because it doesn't reduce the water consumption. And then the two scenarios, reference and INSPIREWATER solution, what you see which are goes to circularity in water as well as zero liquid discharge. And we see that the INSPIRE solution has a higher reduction in the environmental impacts by, it is 60%, and the conventional, the reference solution is about 40%. Another possibilities, we just calculate this, how about desalination? And here we have seen that at that region, in this region here, a desalination, a full desalination would be the best option. Let's come to the costs. We have only calculated the costs for the reference and then INSPIRE. And what we see here, that here the costs are quite higher, which are factor 2 to 2.5 higher than in the baseline scenario. So the overall eco-efficiency is about neutral, which means we have 2 times higher costs and 2 times lower environmental impact. So it's about equal. Now, the conclusion from this project is that LCA and LCC is not only feasible, but it provides really valuable information. And what is really important, I think, as also it has been told before, that it is important to really not make it at the end, but really to start in the project with LCA and LCC, so to combine during the project to revise the results and to take the insights into further technology improvements. And also what we could show is that the INSPIRE solution have both from an environmental as well as an economic point of view advantages over the baseline and the conventional technologies. So thank you for your attention.
Thank you very much, Fredy. So with what you concluded, it would be very easy to say for the companies, okay, we have economic but also ecological improvements, so let's go for the new technologies. But what do you think were obstacles still in that the companies don't do it like directly, although like maybe the numbers here are pretty clear?
Thank you for this question. That's a really good question. No, so the experience in these cases, but also in others, is that some companies they really go for, as for example we have seen in Sandvik. In other, sometimes, let's say the LCC is good, but for example there are high investment costs, and this can be an obstacle to go for. And of course there are also obstacles coming from, let's say, more the management, which means we have done it always the other way, and how we will do, there are uncertainties how to do it.
Mm-hmm. Do you have an idea about the LCC for the desalination in the Clariant case?
No, we don't have it. Because we hadn't the numbers, the cost for it, so I couldn't do the calculations.
All right. So
but
if
that
there are
would
any
be...
more questions to Fredy, please ask them via the open or private chat, and Fredy, I ask you to answer any further questions if there are some coming up. Thank you, Fredy.
Thank you.